Have you ever need to convert units? The answer for sure is yes. Like for example, converting kilograms to grams, converting milliliters to liters, converting inch to centimeters. In order to do this kind of conversions, we are going to use conversion factors. We are going to start with a simple example, like converting inch to centimeters, and after that we are going to continue with a chemistry problem, and there we are going to explain what is the advantage of using conversion factors in order to solve chemistry problems. So let's start with a simple example first and move next after to the chemistry problem. You may know that 1 inch is equal to 2.54 centimeters. We have the right to divide by 1 inch in both sides from mathematical point of view. So 1 inch is going to be simplified totally, and it's going to be 1 equal to. The same happens if you multiply by 2.54 centimeters. Let's try. This here simplifies and is going to be 1 inch equal to 1. These ratios are called conversion factors. So how we are going to use these ratios to convert, for example, inch to centimeters, which to pick and why. So for example, let's try to convert 8 inches in centimeters. So first of all, let's make a simple scheme above. We are going to move from inch to centimeters, from here to here. Now, which conversion factor we are going to use? The first one or the second one? We need centimeters is equal. First place the values that you have. In this case, we have given 8 inch. So we are going to make a fraction here. And you know the fractions are made by numerator, that is this side here above, and by the denominator, that is this side below the line. So at the denominator, you're going to place the unit that you want to simplify. In this case, you want to simplify inches. You're going to write inch here. And at the numerator, you're going to place the unit that you want to go. So in this case, it's going to be centimeter. So let's see the two conversion factors that we generated above. We see that this one here is appropriate to be used here at this ratio. So it's going to be 2.54 and 1 inch. And this is going to be equal to 20.23 centimeters. Now let's move to a chemistry problem that involves several steps and involves several conversion factors. So, how many grams of oxygen are produced during the chemical decomposition with heat of 100 grams of potassium chlorate, solid in the presence of manganese dioxide as a catalyst? First thing that you are going to do in a given reaction, you're going to balance it. In this case, you see that potassium is okay, chlorine is okay, but oxygen is not balanced. So in order to balance oxygen, we are going to place 3 here and 2 here. But also we are going to place a 2 here in order to balance the potassium and chlorine. So before we place the conversion factors, we are going to make the scheme. So from what we have and where we want to go. In this case, we have only the mass of potassium chloride. A trick for the use of conversion factors in chemistry problems is in whatever unit you are, gram, milliliter, liter, etc., you should go to the number of moles first. And after that, from number of moles, you can go to another unit that the exercise wants. So, because we cannot go directly from the mass of potassium chloride to the mass of oxygen. First, we can go to the number of moles of potassium chloride. After that, we have to go, again, we cannot go directly to the mass of oxygen without going to the number of moles of the oxygen. So we are going to the number of moles of oxygen. And from number of moles of oxygen, we can go to the mass of oxygen produced by 100 grams of potassium chlorate. It is advisable to make this scheme before you place the values because it's simple to generate the conversion factors. Now we are going to start our calculation by placing first what we need to find. So we need the mass of oxygen is going to be equal. After that, we are going to place what we have. We have the mass of potassium chlorate, that is 100 gram potassium chlorate. Always place the units, because by placing the units, you can simplify that step by step and you make sure that you are not doing any mistake. So let's place the fraction or the line, and as I said above, we are going to place, without knowing what is the conversion factor to move to moles, we are going to place the units that we want to simplify and the units that we want to go. So in this case, we are going to place at the denominator the gram of the potassium chlorate, because we want to simplify. And we want to go to moles, so we're going to play mole. We are going to place mole here. But what are the values to place here at the numerator and to the denominator? Take a look. It's mole and gram. You know a unit that is called gram per mole, that is molar mass. But in this case is reverse. But as we explained, from inches to centimeter and centimeter to inches is the same. So even here we can reverse the molar mass. Like in this case, 1 mole is going to correspond to how many grams of potassium chlorate? To as much as is given by the periodic table. You are going to find that on the periodic table. I have already done the calculation, is 122.5 grams of potassium chlorate. Multiply another fraction. Now we are going to move from moles of potassium chlorate to the moles of oxygen. In order to do this, where you are going to find the conversion factor? Here you have to take a look at the coefficients at the reaction given above. So you see that you have 2 moles of potassium chlorate produce 3 moles of oxygen. We are going to use this ratio in order to find the number of moles of oxygen. So what we are going to have below and what we are going to have above the line. Simple. You want, I forgot something here. Here is moles of potassium chlorate. So you have moles of potassium chlorate here, and you want to simplify this one because you want to move from this one to this one, to moles of oxygen. So in this case, it's going to be moles of potassium chlorate, and above it's going to be moles, or where you want to go, moles of oxygen. And the numbers here and here, as I mentioned, are the coefficients. In this case, above is going to be 3, because we have 3 oxygens in the balanced chemical equation. And below is going to be 2, because you have 2 from the coefficients here. So if you're going to move from moles of one substance to moles of another substance, you're going to use the coefficients in the balanced equation. Okay. Again, multiply. This continues here. And another fraction here, another line. So what do we have here? We need to move from number of moles to mass of oxygen. How we are going to achieve that? First, take a look at the previous conversion factors. This one simplifies, it is remaining moles of oxygen. So below the line, or at the denominator, we are going to have moles of oxygen. Above the line, or at the numerator, we are going to have grams of oxygen, because we need grams. Gram per mole, again, reminds you the molar mass. So what is the molar mass of oxygen? Keep in mind that from the periodic table, 1 atom of oxygen is 16, but you have 2 oxygens. In this case, it's going to be 32 grams of oxygens that correspond to 1 mole of the oxygen molecule as given by the balanced equation. So this is going to be 39.18 gram of oxygen. This is the amount of oxygen that you are going to produce by decomposition of 100 gram of potassium chlorate. Okay, that's it for this video, guys. Hope you understand a little bit the conversion factors and how to use them in the chemistry problems. Thank you so much for watching, and see you in the next video.